This is the second part of chapter 8. Second video in our channel. Let's start with modifiers. C++ allows character int double data types to have modifiers preceding them. Modifier is used to alter the meaning of the base type so that it more precisely fits the needs of various situations. So the data type modifiers are listed below: signed, unsigned, long, short. Here, the modifier signed, unsigned, long, and short can be applied to integer base types. In addition, signed and unsigned can be applied to character, and long can be applied to double. The modifier signed and unsigned can also be used as prefix to long or short modifiers. For example, unsigned long int. Like this also it can be used. C++ also allows a shorthand notation for declaring unsigned short long integer. That is, you can use simply the word unsigned short or long without the int. The int is implied. Automatically it will be considered. See here. Before we go to that, here signed means represents both positive and negative range. A data type which allows you to represent both positive values and negative values. If you are using signed, you will be able to provide both negative and positive values. Whereas unsigned means you can have only positive values, where negative values will not be there. Here there is a table. So as like see, unsigned A is similar to unsigned int A. Even though if you don't write, it is considered as unsigned int A only. You can write this shortcut, or you can write completely unsigned int B. So now here, when we write only character, it is a signed character, remember. It's a signed character. You need not to use a keyword signed over there to say that it is a signed data type. Just if you write the data type name, it is signed only. If you want to make it as unsigned, then you have to use a keyword unsigned. By default, data types are signed only. So what you need to know here, the keyword for signed, what they use, and the keyword used for unsigned, and how many bytes and how much range of values they represent. If it is a signed, negative side, positive side, how much it represents. If it is only unsigned, then positive side, how much range of values it represents, that you need to know. And it is given in detail here, that kindly check it out. And then these are all C++ modifiers. Usually int, character, short, long. Only these three. For this, by default, these are signed. If I write only int, character, short. If I write unsigned int, unsigned character, unsigned short. Similarly, unsigned long int also we can use. For int, we can apply this keyword also, which is signed. Whereas for float, it is simply just float, it's a signed one. Double is also signed one. Long double, which represents still larger range. They're all these data types which represents decimal values, real numbers. They're all signed only. There is no unsigned in it, right? So now here, derived data types. These data types are constructed using simple or fundamental data. They include arrays, functions, pointers, and references. So in the further chapter related to this, there will be a detailed study. User-defined data types. So here, the data types are also constructed using simple or fundamental data types. Some user-defined data types include structure, union, class, and enumerated. We shall study about structure, union, class in the further later chapters. Now here we are going to study about enumerated data types. Enumerated data types are basically used to define a set of named constants. That means, like in the last class, we had seen that if I want to declare any constant, I must write const float pi equal to 3.142. So here, this is the assignment operator, remember. The const keyword is used to define the constants. That means the value of pi cannot be changed during the program execution. But when we want more constants, like say assume that constants can also be defined as hash define pi 3.14. Like this also we can do it. Suppose assume that we want to define constants for the weekday names. How you can write hash define Monday means 1. We'll say 0, or Sunday will make it 0. Then similarly, Monday 1, and here Tuesday 2. Like this you have to define for all the weekdays. That means what? Wherever I wanted to represent the weekday names with the serial number in the programming statements, now wherever I want to represent Sunday, I need not to write 0. I can just write directly Sunday. If we do like this, what happens? While reading the program, the compatibility will be more, right? So this, instead of writing these lengthy statements in more number of lines, what you can do, we can have enumerated data types, which will help you to define series of constants in a single line. So let us see here how to define the syntax enum, tag, and the enum list. Enum tag declarator, for declaration of variable of type tag. Enum tag, there must be a space. Here you see enum choice, very bad, bad, satisfactory, good, very good, excellent. Choice, my choice. Enum, my enum type alpha, beta, gamma. Here alpha takes 0, beta takes the value 1, gamma takes value 2. That means we can write like this. Enum, weekday, Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. We do, you have to use braces. Okay. So if you do like this, what happens is Sunday, value 0 will be assigned to Sunday, 1 will be assigned to Monday, 2 will be assigned to Tuesday, and it continues. Right. With this, what I can do, I can declare variables also. Weekday W1. This kind of variables can also be declared. And one more thing is, always it takes the first value, it assigns 0, second value it assigns 1. This series continues. But the situations will not be always like this only. We want to give our own value. For example, I'll write enum, grade of student. Here I'll write, say rank. Rank means its value is 95. First class, its value is 60. Second class, its value is 50. Pass, I'll write 35. They should be separated by comma. And then fail, it is say 34. You can give your own values. This is possible. Along with that, yes. Along with this, what we do is enum, say I'm writing sample, where I'm writing some name, say A equal to 5. My next constant is B, C, D, E. So what happens now? Where first value, usually what happens if you are not giving any value, first value will be taken as 0, second will be 1, next will be 2, like that. But whereas the first value, I have assigned it as 5. So automatically that series starts 5, 6, 7, 8, 9, like that. That means A is 5, B is 6, C is 7. Like this, it continues. And now here, enum type conversion rules. Whenever we declare the enum variable or when we are assigning the enum variable to some other variable, then what kind of conversion rules will be there? These rules apply to C++ only, not for any other language. And there is an implicit conversion from any enum type to int. See, enum, my enum type, alpha, beta, gamma. Alpha means how much? 0. Beta means how much? 1. Gamma is 2. So then the following lines are legal. They are valid. If I write int I is equal to beta, can you tell me what value will be assigned to I? It will assign 1 to the variable I because it is in the second place. Int j equal to 3 plus gamma. Gamma means how much? 0, 1, 2. It is 2. Plus 3 is 5. These are all valid. On the other hand, C++ does not support an implicit conversion from int to enum type. This is not possible. Enum to int type conversion is possible. Reverse is not possible. For example, my enum type x. X is a variable of type my enum type enumerator data type. Yes, we are assigning integer value 2 to the x, where 2 is an integer value, x is a enum type. This conversion is not possible. My enum type y equal to 123. This is also not possible. Right. Note that it does not matter whether the int matches one of the constants of the enum type that time also it is not possible. That means they say that sample T, I have declared one variable of type T. Wait, directly T equal to phi L, right? You know that in the above enum type, phi is assigned to A. Now what I am doing is I am assigning phi, an integer value, to the enum type sample variable T. This is not possible, even though phi is the value given for the enum values inside the declaration. That time also it is not possible. Overall, from int to enum type conversion is not possible. Yes, this is the completion of chapter 8. Everyone check this second part also. And the next class, we are going to start with the 9th chapter. Yes, we will be continuing all the complete syllabus from your textbook. And soon after completing PUC first year CS syllabus, we are going to continue second year syllabus also. So everyone kindly be in touch with our channel for latest updates. Subscribe. If you have not subscribed, please subscribe it. Like our videos. If there are any doubts, comment it. Even we conduct online coding classes, live and online coding classes will be there. If anyone interested from your group, so kindly intimate to us. If any of your friends, relatives, I mean like brothers, sisters, or known people who are in engineering, if they want to, if they are willing to do any coding classes, then kindly connect it to us. At the end of this video, our contact numbers are there. You can contact us for online coding classes. Thank you. Bye everyone. Have a nice day.